Hi everyone, I'm going to be doing a video today focusing on the exercises that relate gravitational potential energy and kinetic energy. So as you guys know, and if you don't, go on my videos and check the videos on gravitational potential energy and kinetic energy and get to know what they are and their formulas. But as you guys know, these two energies, they when you have movement, something is falling from a certain height or you're sending something high up, these energies, they transfer between each other, okay? So, for example, I have here a pendulum and my pendulum is moving. Now, when the pendulum is at the equilibrium position, it's moving quite fast, so it has the maximum kinetic energy, but it has no height, so it has zero potential energy. However, as the pendulum moves to the highest displacement, then it has zero kinetic energy because it's going to slow down until the velocity is zero, and then it's going to change direction and move on the other direction, okay? So zero kinetic energy, but maximum gravitational potential energy because it has a maximum height. The same when it gets to the other extreme. So basically what happens is, as this pendulum is moving, my kinetic energy goes from a minimum value at the maximum displacement to a maximum value at the equilibrium position, all right? And then minimum again, while the potential energy does completely the opposite, so it's completely different. It goes from the highest value at the maximum displacement because it has the highest height, is zero at equilibrium, and then it rises again until it reaches its maximum at a highest displacement. Now, if I would add these functions at all times, I would have a total energy in that system to be the same number and constant throughout. So my total energy doesn't change. This is, of course, assuming that my system does not have any air resistance or any frictional forces that would make that some work would be done against friction or an air resistance, okay? So that some energy would go and be wasted as heat, okay? So my total energy is the same. So that means that kinetic energy and potential energy are constantly converting into one another. So there are going to be various exercises that you're going to get, many of them to do with roller coasters or sliding down a slope, where they will give you information about, for example, kinetic energy, but they will ask you stuff about the gravitational potential energy. And so many times my students get completely lost and they're like, I have no clue how to do this because I don't have the information to calculate, for example, potential energy. So the trick is to remember that the change of gravitational potential energy equals the change of the kinetic energy. And it doesn't matter the shape of the roller coaster or the shape of my slope. If I play around with the energies, I'm going to have the right answer. I just need to remember that if I do not have any friction, all my GPE is going to be converted to all my kinetic energy and the other way around, okay? So let's see, for example, what you can do, and let's see two exercises where we apply this. So how do you do these exercises into 3 simple steps without failing them, without, losing marks? The first thing you do is you check what is given to you. If you were given mass or force and height, you can calculate GPE, so give it a go, calculate GPE. If you are given mass and velocity, go ahead and calculate kinetic energy, okay? So if you were given these things, calculate whatever energy you have. And then remember that that energy you calculated is equal to the other energy you did not calculate. So GPE is equal to the kinetic energy. If you calculated kinetic energy, make it equal to GPE, okay? And then, after you have that number equals to GPE, for example, then write that number equals to the formula. And then from the equation that you made the first energy equal to, manipulate the equation until you get the variable that they are asking you. So change the subject of the equation to get the height or the velocity or something else, okay? So in 3 really simple steps, you ensure that you're not losing any marks in exercises where you have a transfer of gravitational potential energy into kinetic energy or the other way around, okay? So let's try this exercise. They say calculate the speed of a 1,000-kilogram roller coaster at the bottom of its ride. Ignore friction. After diving it from its higher point, which is 20 meters up, the roller coaster had no speed before starting to fall. At the end, they also want you to draw a diagram where you show the part of the roller coaster, okay, and label the following in the diagram: maximum GPE, maximum kinetic energy, 0 GPE, and 0 kinetic energy. Alright, so let's do this. I was given the mass and I was given the height. I can calculate GPE. Okay, so GPE is the force of gravity times the height, so the mass times the gravity times the height. So the force of gravity is going to be 1,000 times, to be honest, I should have done 9.8, but we were doing this, by head, so 1,000 times 10, which gives me 10,000 newtons, okay? That's my force of gravity. So GPE is going to be 10,000 newtons times the height, 20 meters. So that means that my change of gravitational potential energy as I go from the highest point of my ride to the lowest point where my speed is maximum is 200,000 joules. Alright, I calculated the variable that I could, or I calculated the energy that I could with the information they gave me. Now I'm going to put that energy to be equal to the kinetic energy, because assuming that I have no friction, then all my gravitational potential energy goes into kinetic energy. So I say, my change of kinetic energy is equal to 2,000 joules. In the beginning I had 0 kinetic energy, at the end I have 200,000 joules. So I'm going to do the following. I get 200,000 joules equal to the formula for kinetic energy, 1/2 times the mass times velocity squared. I move around the equations if I want, or in here I'm substituting the values. 200,000 joules equals 1/2 times 1,000 kilograms times velocity squared. So if I move this equation around, I get 2 times 2,000, 200,000, so 400,000 divided by 1,000. I get 400, 3 zeros, divided by 1 with 3 zeros. So they cancel out, I get 400 as velocity squared. If I take the square root, I get the velocity, which is 20 meters per second, okay? So this is how I do the exercise, alright? It's very simple, and I only needed 3 steps. And here it is. It doesn't matter the shape of my roller coaster. The maximum potential energy is at the highest point of the ride. The minimum potential energy is at the lowest point of the ride. My maximum kinetic energy is when my potential energy is minimum. So at the lowest point of the ride, my minimum kinetic energy happens when I have my maximum potential energy, so at the highest point of the ride, okay? Let's try a couple more exercises. As an experiment, a 2-kilogram box is left to fall from a window 30 meters above the ground. What is the gravitational potential energy of the box before it falls? I'll go back to the slides to go on the other questions. Alright, let's do this one. GPE is the mass times the gravity times the height. The mass of the box is 2 kilograms. Gravity, you should do 9.8. I apologize that I did 10. 10 is alright, but you should really go for 9.81 times 10 times 30, which is the height. So it gives me 600 joules. Alright, that's the GPE. What is the kinetic energy of the box just before it hits the ground? Well, if all my gravitational potential energy is converted to kinetic energy as I fall, then my change of GPE equals my change of kinetic energy. So assuming that I have no friction, the kinetic energy just before it hits the ground should be as the same, 600 joules, okay? Next question. What is the velocity of the box just before it hits the ground? So what I do is I pick the 600 and I make it equal to the kinetic energy, okay? So I'm doing that step that I told you on how not to fail. Make the energy that you calculated equal to the other one. So kinetic energy equals 1/2 times the mass times velocity squared. So if you cannot change the equation straight away, substitute values, but my velocity will be equal to the square root of 2 times the kinetic energy, 2 goes there, divided by the mass goes there. And then I have the square, so I need to do the square root. So it's 2 times 600 divided by 2, all under the square root. And it gives me 24.5 meters per second, okay? There is an alternative way to do that. I can simply just say GP equals kinetic energy, so mass times gravity times height equals 1/2 times the mass times velocity squared. Masses, they can cancel each other out, meaning I don't even need to give you the mass of the box for you to calculate what is the velocity after it falls a certain height. So I get gravity times height equals 1/2 times the velocity squared. So velocity equals the square root of 2 times the gravity times height, which is 2 times 10 times 30, 24.5 meters per second. It gave me exactly the same answer. Okay, so you can do it several ways. 1D, a student uses a very accurate equipment to measure the velocity of the box just before it hits the ground. Do you think the box's velocity will be higher, the same as, or lower than the velocity calculated in the question before in 1C? Now, I calculated that the velocity should be 24.5 meters per second. However, this is assuming that there is no friction, no air resistance, meaning I am not getting energy wasted as heat or sound because I am not doing any work against friction. In reality, that's not what happens. I have friction due to the air resistance, or I have therefore I have air resistance, a frictional force. So the box's velocity will be lower than the velocity that we calculated because in reality I have some energy or some work done against friction. Let's do the very last exercise. A skater is performing a stunt where he jumps from one platform to the next. For him to be successful, he must leave the first platform with a velocity of 30 meters per second. The skater gains its velocity by rolling down the ramp. What is the minimum height the skater must start rolling for him to be successful? Now, I only gave you one thing. I only told you the velocity. And I'm asking what is the minimum height for him to leave the ramp at that speed, at that velocity. Now, I didn't give you the mass, but you saw in my alternative that you actually don't need a mass. So let's try to do this exercise. It's the hardest one, okay? So, gravitational potential energy is going to be equal to the kinetic energy in terms of changes. So, mass times gravity times height, which I mean the gravitational potential energy formula, equals the kinetic energy formula, 1/2 times the mass times velocity squared. My masses cancel each other out. I don't need a mass. So I get gravity times height equals 1/2 times the velocity squared. If I change it to get height, I get g going and dividing on the other side because it's multiplying here. So I get velocity squared divided by 2 times g. So 30 squared divided by 2 times 10, if you don't have a calculator, or 9.81. And this gives me 45 meters. And there we go. This is how you do exercises that are about losing gravitational potential energy and gaining kinetic energy, or the other way around. I throw something up in the air with a certain velocity and I want to know how high it can go. It's really simple. You just need to remember to make the change of one equal to the change of the other, okay? This is a higher end exercise, so if you're not getting this completely, don't freak out, but it's challenging the most able students or the students that want to, or anyone, students or not, that want to practice this a little bit more, okay? So I hope it made sense for you. If not, talk to me or message me directly. Up to my next video. Be happy and healthy. Bye!